Students, today we'll be talking about motion and measurement of distance from class 6, subject science. The learning objectives in this chapter will be story of transport, distance, unit, standard unit of measurement, conversion from one unit to another, development of the skill of measurement, motion, and the types of motion. Students, in the early times when there were no means of transport available like buses, cars and trucks that are available today, the human beings used to walk on foot. Sometimes they would carry their goods on their own back or on the back of the animals. Some time later they could develop very simple kind of boards which were nothing but the pieces of wood flatly tied together. They were hollow woods which could float on the water bodies. They probably took inspiration from some aquatic animals like fishes, and they improved upon the design of their boats, which later on became streamlined in shape. Now these boats were much more efficient than the earlier ones. Then came a very important invention, which was the invention of wheels. Now these wheels could make the animal driven carts possibility. And so the bullock carts came into picture. This really reduced the burden of transport from humans and animals as well. In the early 19th century, the steam engines were developed which could make the railway network possible, and the public transport was now much more efficient. With the invention of the internal combustion engine, the personal transport was also possible after some time. We see that the railways have undergone a lot of changes with time. In the earlier times, the planes that were developed were very simple in structure. Now we see very different kind of aeroplanes. The ships, boats also took different structures with time. Now these are some pictures of the modern day transport. We have car, which is fitted with an internal combustion engine. We have monorails, we have supersonic jets and spacecraft, which are all the modes of transport that are available today. Students, let's talk about distance. What do we mean by distance? Suppose if I tell you that the distance between Delhi and Bhopal is 760 km. Now what does this 760 km signify? This 760 kilometers signifies that for a person who has to travel between Delhi to Bhopal has to cover some length which is equal to 760 kilometers. So this distance is nothing but the length of the path between the initial and final position. Now this is called distance. Now what about measurement? Students, why do we need to measure things? We measure things almost on day-to-day basis. Like suppose when we have to cook something, like if we have to cook some cereals, rice or dal, we generally take some sort of measurement how much katori of rice or dal has to be cooked. So in day-to-day lives we are always doing some kind of measurement. If I ask you to measure the dimensions of this room, what will you do? You will probably bring some measuring tool and try to measure the length and breadth of this room. Now the architects who have to develop the buildings and other infrastructure, they need to have precise measurement before beginning their activities. Similarly, if we have to get some clothes stitched, we will go to tailor and give it to him some piece of cloth which will have some specific measurements, out of which our particular kurta or anything can be stitched. Now the tailor also needs to take the personal measurements of ours to stitch the fabric. If we go to vegetable vendors or fruit vendors, we need to specify them how many kgs of fruits or vegetables do we need. So we'll have to mention, like we need 4 kg of apples or 2 kg of some other eatables or whatever is the scene. Sometimes you also measure your height, and when you do your measurement of height, you generally report it like 5 feet 3 inches or 4 feet 9 inches. So all these are measurements. So what are we doing in these measurements? We are actually trying to compare some physical quantity with some kind of reference. Like suppose if I say that the particular fruit basket was of 4 kg. Now what am I trying to do? I am trying to measure, or I'm trying to compare the weight of this basket with some reference. Now here what is the reference? The reference is kg. Now this particular thing, that is kg, is called our reference or unit. In the picture that are given here, in the picture of the classroom, if we measure the length and suppose it comes out to be 6 feet or 8 feet, then the feet is our reference or unit against which we are doing our measurements. So what is unit? Unit is nothing but a fixed quantity with which we compare an unknown physical quantity. Now what is the unknown physical quantity? The unknown physical quantity can be the length of this piece of cloth, the weight of this particular fruit basket, and the reference is in this case kg. In the case of fruit basket it is kg. In the case of the piece of cloth it can be meter. So these are the reference. So the unit is a fixed quantity with which we are trying to compare an unknown physical quantity, which in our previous examples were length, breadth, weight, height. So all those were physical quantities, and we had certain units against which we were making our measurements. So some of the popularly used units are: for length we have been using meter, centimeter, inches, feet. For weight we use pound, kilogram, gram, and other such units. Now let's try to make it clear. Suppose if I ask you to measure the length of this pencil, what will you do? You will probably bring a scale and will try to measure the length. Suppose the length of the pencil comes out to be 10 centimeter. Now this 10 centimeter is the result of the measurement. You can see that this result has two parts. 10 centimeter has two parts. One is the number magnitude, that is 10, and the other is centimeter, which is our reference as we discussed, or unit. Now this number 10 is unknown quantity and unit is the known quantity. How do we say that it is unknown quantity? Because when we did our measurement, we were able to know that the length was 10 centimeter. But this unit or centimeter is already known to us. The idea of centimeter is very much known to us. If on the scale we see, then one particular unit, if there is a 15 centimeter scale, then one particular unit or division of the scale is known as centimeter. So the idea of centimeter is known to us. But what we are trying to know is the length of the pencil, which was 10 centimeter. This 10 centimeter can also be written as 10 into 1 centimeter, which tells us that the pencil is 10 times that of the length of a centimeter. So here it tells us that pencil was 10 times the length of a centimeter, or we are comparing the length of the pencil with this known unit or with this reference, that is centimeter. So measurement is nothing but comparing an unknown quantity with a known quantity. The result of measurement has two parts. One is unknown quantity, which is also known as magnitude, and the other is the unit or our reference, which is a known quantity. Earlier we did not have such units, and the units that we used were non-standard units of measurement. Now what do we mean by non-standard units of measurement? By saying non-standard, we mean that there is something which is arbitrary, which is not fixed according to some logic, which can help us in doing our task at hand, but cannot be very much reliable or cannot be taken as standard. We'll discuss few non-standard units of measurement which were used earlier and we still use them sometimes. Like the concept of yard. The length of the yard was taken to be the length between nose and the tip of the middle finger with her arms stretched out. We also had some non-standard units of measurement like hand span, the length between the thumb and the little finger, then cubit, which is the length between the elbow and the tip of the fingers, foot span. So all these measurements you probably have seen in usage. Some other non-standard units of measurements that have been popularly used is angul. Angul, which is the size of a finger, a fist or a mutti. Sometimes we take a handful of certain item in our mutti and we try to have a rough estimate of a particular quantity. Bowl, which we have discussed that our mothers in the kitchen for the day-to-day activities, they use cup or katori, or we can say bowl, for daily measurements of cereals. Sometimes we also take a piece of stick as a non-standard unit of measurement to measure anything. Some other examples of non-standard unit of measurement is like, suppose if the children play in the playground, they often mark the boundaries for various sports activities. Like suppose if they are playing kabaddi, they need to mark the boundaries. So for that purpose, they might be using foot span. So because of convenience, they use foot span. Then there we see a picture of a handful of chips or a mutti of chips. So it also gives a rough estimate of the quantity. Bowl of cereals we have already discussed. And in the earlier times, to measure weights, people would use certain stones as standard, and they will measure anything in quantity against this reference. So these kind of units were non-standard units of measurement. There is problem with the uses of these kind of measurements because it creates confusion, because it lacks uniformity. That means, as I have already told, that these things are not fixed by any logic and they may change. So they are not valid at every place. It can help us in doing our things at the moment, but it's not useful for a society which has larger boundaries, or you can say that in the globalized world where a lot of people need to interact with each other, people across countries need to interact. So this kind of unit of measurement will only create confusion. Now how it does confusion can be explained. Suppose if I ask you to measure this particular table and you decide that you can use your hand span to measure the table, and suppose if your result for the measurement is 4 hand span. Now if someone else asks you that what could be the length of this table and you tell them that it is 4 hand span, the person might get confused. The reason for confusion will be that the person may not be knowing what is the actual size of your hand span. So for him 4 hand span will hold no meaning. Again, if we take a group of people which have different sizes, then people having different sizes may have different body parts sizes and their hand span may be also different. So if they measure the same table with their hands, they may get different results. Some may get 5 hand spans, some may get 4 hand spans, some may get 3 hand spans. So there is no uniformity in this kind of measurement. So because of this non-uniformity, there will obviously be confusion. Different people have different body sizes, so they have different sizes of their hand span, foot span, cubit, etc. And that's why there is confusion. So to eliminate this problem and to bring uniformity in measurement, we use standard units of measurement. In 1790, French created a standard unit of measurement which was based on metric system, called metric system. Some standard units that we have been commonly using is, for length we have centimeters, inches, feet, kilometer, etc. Weight, gram, pound, kilogram. So these units of measurement, since they are standard units of measurement, their value is not going to change. So these units will have a fixed value which will not change with the change in place or with the change in the people who are using it. But with those non-standard unit of measurement like hand span, angul, foot span, the size of those units will change with different people, because every person do not have the same size of those hand span, cubit, foot span, so that will be confusing. But here since these are standard units, their value will not change, and wherever you go in the world you will have the same value of a centimeter, of an inch, of a pound, of a kilogram. Later on, scientists all over the world decided that they have to adopt a system of units which is agreed upon by all, and this system of units were called SI units, or International System of Units. This system of units was based on MKS system. MKS is for meter, kilogram and second. This meter, kilogram and second are some basic units in these SI units, because length, weight and time are considered as basic quantities for measurement. We very commonly use these quantities in our day-to-day activities. So as per SI system, for unit of length we have meter, for unit of weight we have kilogram, for unit of time we have second. So these are the SI units which have been agreed upon or accepted by all the countries the world over. We can use these system of units and it has been accepted by the entire world. Meter, kilogram and second are some of the basic units. Now we discuss these three basic units. There are other basic units also, but yet the number of physical quantities that we measure is more than the number of SI units. So that means we have lesser number of basic units and more number of physical quantities. So how will we measure the other physical quantities which do not have any SI system of units? Those physical quantities can be measured by derived units. So with these examples it will be more clear to you. Like suppose area. The formula for area is length into breadth, as we all know. Now for length the SI unit is meter. The breadth will be also kind of length, so breadth is also measured in meter. Now length into breadth, that means meter into meter is square meter. So the SI unit for area will be square meter. Similarly for volume we have the formula length into breadth into height. So again length, breadth and height, all three quantities will be measured in meter in SI units. So the derived unit for volume will be cubic meter. For speed, since the formula is distance upon time and the distance is length of the path, so the length of the path will be measured again in SI unit meter. And the time, for time we have already discussed that the SI unit is second. So if we keep this with this formula, the derived unit for speed comes out to be meter per second. So for length we can have different standard of units like meter, kilometer, centimeter, millimeter. We can measure lengths in all these units. They are all standard units. But if we want to take measurement in SI unit, we will have to express it in meter. So meter is the SI unit for length. In the same manner, if weight has to be measured, we have different standard units like gram, kilogram, milligram, pound, etc. But if the weight has to be reported in SI unit, it has to be done in kilogram. For time, again we have units like hours, minutes and second. Time can be expressed in any of these units, and all these units are standard units, but the SI unit for time is second. Now these units can be converted from one to another. So here in the middle, as we see that meter is our standard unit. As we are going up, the units are becoming smaller. Like the decimeter is only 1/10 of a meter, centimeter is 1/100th of a meter, and millimeter is 1/1000th of a meter. So these units are smaller than meters. Now if you know the relation between them, you can easily change the units from one to another. As we go down, we see that the units are getting bigger, like decameter, which is equal to 10 meter, hectometer, which is equal to 100 meter, kilometer, which is equal to 1000 meter. So this way we can change one unit to another unit. Now moving on to the correct measurement of length. Students, how we can take the measurement of a length correctly? Here you have two figures, figure A and B. You can see certain differences in these figures, and the differences is due to the placement of scale. Now in these figures, the person is trying to measure the length of the box. In figure A, the scale has been put along the length of the box in a straight fashion, whereas in figure B, the scale is not straight but skewed, and so the result of measurement is not going to be correct in case of B. So whenever we are going to measure a length, our scale should be placed along the length in a straight manner. So figure A is the correct way of doing it. Figure A is the correct way of measuring any length, and figure B is incorrect. Next is that the zero mark of the scale should be taken as the beginning point. Whenever we try to measure something, the measurement has to start with the zero mark on the scale. And in case if the scale is broken or the zero mark is not visible, then in that case we can take a full mark as the beginning point, and the final adjustment has to be made according to the selection of the beginning point. So here again we have two pictures, and we can see that the scale in this picture is broken. So we cannot take 0 as the beginning point with this scale because it is broken. So we'll try to take any other full mark. Here in this case, the full mark that has been chosen as the beginning point is 0.1. And the scale has been put in the straight manner along the length which is to be measured, and we here can see that the final reading is coming somewhere around 14.3. So whatever is the final reading, that has to be adjusted with the initial reading that we have taken. So in this particular case, our measurement should be 14.3 minus 1, that is 13.3 centimeter. So the length has to be adjusted according to the selection of the beginning point. So if the zero mark is not visible, the full mark that was chosen was 1 as the initial reading, and any other full mark can be chosen. Here we have chosen 1. We can also choose 2, 3 or any other full mark, but the measurement has to be adjusted according to the selection of the beginning point. Here in this example, we can see that the scale is broken and the 0 point cannot be taken as the beginning point. In fact, the scale is broken much beyond that point. We can choose 7 as the beginning point because it is a full mark here, but here in this particular case 8 has been chosen as the beginning point. Now if we see, the final reading is coming out to be 10.5 inches. Now what should be the actual reading, or what should be the actual measurement of this particular pencil? Now we see that the final reading is 10.5 and the initial mark has been chosen as 1, so it has to be adjusted with our final reading. So the actual length of this pencil has to be 10.5 minus 8, that is 2.5 inches. Now about the correct measurement of length, another thing that is very important is the position of our eye. Now here you can see there are 3 children who are trying to take the final reading of a measurement, and they are at different positions. The position A is to the left of the final reading, while the position C is to the right of the final reading, and B is directly above or just above the final reading. So in this case, what do you think is going to have the most accurate measurement? Certainly B position is going to give the most accurate measurements, because the other 2 positions are not directly above the final reading, so they will have some kind of incorrectness. So placing our eye is also very important at the correct position. So our eye has to be exactly above the final reading. So in this case, the final reading is 7.5 and the most correct result will be given by the position B. Students, a curved line cannot be measured with the help of a normal scale like the plastic scale that you use for your measurements. So the measurement has to be indirect. For this purpose we need a thread. What we can do that if we have to measure the curved line from point A to B, we'll try to place our thread at A position. For convenience we can tie a knot in the thread and we put the knot at this A position. Then we'll try to measure the next straight portion of this curved line, howsoever small it may be. We'll try to measure the straight portion of this curved line. Then we'll proceed along this curved line by measuring small measurements of the straight portion, and we'll proceed like this up to the point till we reach the B mark. Here again we can tie our knot and then we will keep the thread straight and we'll try to measure the thread between these two knots on a scale. This way we can do the indirect measurement of the curved line. So there are certain things that we cannot directly measure and we have to do some other techniques like these indirect techniques as explained to measure such kind of lengths.